Mic check, 1, 2. Mic check, 1, 2.
Hello. Hello. Am I coming through? Jason? Testing 1, 2, 3. I can hear you drinking something. Hello.
Hello, Rancheroos. It's time for the Ranchcast. It's 12 p.m. Eastern Time, and let's get started. So, today we're doing something a little bit different. We're going to be talking to Austin Parker of LightStep, and he's going to actually demo distributed tracing. So, before we get started, let's go ahead and go through our normal everyday homework. So, if you'd like to join us today, you can do so by going to slack.rancher.io, putting your email in here, and you'll get an invite from us, and you'll be able to join the Slack Rancher users workspace. And if you join the workspace, navigate over to the Ranchcast channel. If you're in there, feel free to say hi. I'll be monitoring the channel throughout for questions. And I'll make sure to feed those over to Austin. So this is my first time trying to do one of these with live video or with Zoom. So I was having some issues with the audio setup. Let's see if this works. So I'm just going to probably unmute all my mics when I get over there. Let's do a Zoom split. Austin is on. How you doing,
Hello.
Austin?
Hi, can you hear me?
Oh, still can't hear me. All right, I'm going to unmute everything.
How about now?
Any better now?
I can hear you.
Yep, he can hear me. I can't hear him.
You
so
can
I'm
or
gonna mess
can't.
with Zoom settings for a second because Zoom is fun. See, Zoom can hear me and I can't hear him, and I can't figure out why. So let me just leave computer audio and come back in.
Not showing up on.
Any better?
I can hear
You
you.
can still hear me.
Yeah. I'm not seeing myself.
Let's try this. How's that?
I can hear a
Nope,
lot of things.
Still
now.
can hear me.
I can hear a lot of things.
All right. Let's try
hold on,
same as system and same as system.
Hold on a second.
Unmute and increase volume. It thinks I'm muted. Austin, you hear me all right?
Yeah.
Yeah, he does hear me. I just can't hear him, and I can't figure out why. And I don't know if you can hear him because OBS will not tell me. So I'm going to try to see
I
if
can hear me on
I
the
adjust
stream.
my audio settings to see what's going on here.
I can hear me on the stream.
Let's see, settings, and audio. All right. We've got stereo, I've got desktop audio. Let's try this one. Apply. Do I have more audio channels? All my audio should be working. Everything is on. And Austin is on. You know what? Let's kick Zoom. So we're going to kick Zoom real quick.
Alright, want to recall?
And try this one more time. So Austin, would you mind rejoining? I'm going to kick Zoom.
Yeah, I'll join.
All right. And let's make sure my Windows sound settings are working. Oh, is that... Okay, I can hear sound on my mic. We've got sound coming from all over the place, which is good. Let's try this one more time.
The fact that you're not
Hey,
saying.
I
Hey.
can hear you.
You can hear me.
Look at that. We just had to kick it.
Hey.
All right,
Let's
let me-
turn it off and back on again.
Yeah, go figure. I have no idea why that worked. So, welcome to the Ranchcast.
It's good to be here.
Yeah. So, for those of you who don't know me, I used to work for a company called Apprenda, along with Austin, who worked over in R&D. So we're old colleagues. I ran into KubeCon last year. Thought the stuff he was doing in tracing sounded really fun, and figured I'd have him on. So, tell me about tell me about tracing, how that works in Kubernetes, and what you're doing over at LightStep.
Yeah, so yeah, hi, hello. It's been a while. So I guess let's talk about distributed tracing for a second. I think this is it's a new term of art, kind of. There's been this concept for a while of monitoring, right? Like, you're running an application, you need to know what's going on. And over the past several years, I think you've seen this sort of sea change almost in among people doing operations and DevOps and running software that is led to the adoption of something called observability, which is taken from control theory. The basic idea is it's the sum of the outputs of a system, right? Can you control a system using only its outputs? And those outputs are things that are, some of them are pretty boring almost. Like, how much RAM is my container using?
All that machine data.
Host, right? All that machine data, host level data that Kubernetes or whatever is going to give you. And so for a while there's been this idea of kind of pillars of observability, right? There you've had metrics, which are your, like, hey, this is a how much CPU I'm using, how much RAM I'm using, whatever. Or it's sort of things related to that, right? Like, how many requests per second is my service serving? The second one is logs, right? So your logs are just going to be your log statements. My code did a thing, right? And the third pillar is distributed tracing.
Okay.
And distributed tracing what's interesting is a lot of, if you go and you kind of look at the both open source marketplace and kind of the general vendor marketplace a little bit, you're going to see a lot of companies are kind of selling you three different things. Like right now, if you go, I think, last week Splunk bought, or a couple weeks ago, like a month ago, Splunk buys SignalFX, and then a couple weeks ago they buy Omnition, which was a distributed tracing startup. And you look at Datadog, and they've got a metrics product and a logging product and a distributed tracing or APM product, And there's this whole kind of movement towards like, oh, everyone has sort of accepted, hey, we need observability, and that means we need these three SKUs to give you so that you can, do observability. Yeah. On the open source side, you've got that too, right? You've got
scale is hard.
Yes, scale is hard. And then on the open source side, you've got, hey, I need Elk Stack for logs, I need Prometheus for metrics, and I need like Jaeger or Zipkin or something for traces.
Cool. So where does LightStep fit in all this?
So LightStep, we approach it sort of, I guess, in a more modern way, I would think, right? A lot of these traditional ways of thinking about observability kind of lead you to the idea that, well, you need a bunch of dashboards, you need separate sort of, I need my logging dashboard, and I need my metric dashboard, and I need my tracing dashboard, right? And our thesis really is that tracing is kind of all of these things in a big way, right? A trace is really a structured log with metadata built in.
Okay.
The basic idea of a trace is that, in a microservice-y world, is that I've got a bunch of services that are doing work, and I can measure that work. I can say, service foo handled a request in 12 milliseconds in a span of time, right? Mm-hmm. And we use that span as an abstraction to attach events to, right? You can attach attributes like the host name of the container that handled the request, or the customer ID that's associated with it, right? Mm-hmm. And then I can add events like long form log looking events like, hey, this failed, so here's a stack trace. And I can also add things that look a lot like metrics when you aggregate them.
Okay.
After the fact.
So it sounds like metrics on steroids.
In a lot of ways, right? It's metrics and logs on steroids, kind of, right? I can, for the most part, you can make a dashboard for your system, and you can have a billion different things that you're getting metrics of and aggregating and saying like, oh, okay, I can see my little happy lines go up and down and left and right. But to kind of an end user, to a consumer of your service, what do you really care about? Operations per second, um, latency, and error rate.
Your golden signals, essentially.
Yeah.
Yeah.
And so tracing is a way to give you all of these things and also give you really actionable information. So one of the things that separates, I think, tracing from just pure metrics or pure logging is that with a trace, I actually get a really detailed view of the life of a request as it moves through my system. So I can see, starting at my client, and that might be a browser or a mobile application or an ATM. But whatever, the first kind of thing is, I can say, from this point, let me see every step in the chain, right? I get a little flame graph looking deal, which I can show off. I'll show off here a little later.
Mm-hmm.
But I can actually kind of step through each hop, each RPC. I can inspect, like, hey, what's going on here? And that's really powerful if, I'm at a big enough organization where maybe my team doesn't know, maybe we know the direct consumers of our service, but maybe we don't know the second or third or fourth order consumers, right? Maybe I'm a front end person and I'm getting bug reports that say, hey, it's really slow, or sometimes I hit this, button and things don't work.
Yep.
So who knows, right? There could be a billion different reasons for that.
Oh yeah, having as much data as possible to troubleshoot and postmortem an issue. Yeah,
Exactly.
I can see the value there. Well,
yeah.
Well, since a picture's worth 1,000 words, and we're running at 30 frames a second, why don't I just let you show this stuff off?
Yeah, sure.
So here, I'll give you this. So the screen is now yours.
Okay, let me. So I've actually got a couple different things here. And I'll let you sort of choose your own adventure. Do you want to see kind of what we're doing now and then talk about the future, or do you want to talk about the future and then see what we're doing now?
Let's start with now and then go to the future.
Let's start with now. Okay, so let me share some stuff. Let me make Zoom cooperate. All right.
We're just beating Zoom into submission today.
Yeah.
All right. The share's working.
All right. So you see this application, Donuts as a Service, right? We've got our own. Is this actually cut off on your screen?
I don't believe so.
Let me try
wait a second.
it.
I did crop. I think I did crop some things slightly because of where the borders were. Let me fix that really quickly. Yeah, we're just having all kinds of fun on the fly because this, like I said, first time I've done a Zoom.
Well, I'm glad to be a guinea pig.
Yes, thank you for being my guinea pig, Austin. All right, we're just gonna. Of course, I'm on the machine where all of my inputs are used up by OBS, so I don't have an extra input for my mouse. So, all right, that is much better. So let's try this. There. Now we have a full browser window, minus the little bit of the logo down the lower left-hand corner.
All right, so what I've got here is I have a this is a sample app, and what this is it's a little bit of an over-engineered thing, right? So let's imagine that I started my cool new startup that delivers you donuts or makes you donuts, right, as a service. So I can go through here and I can build a cart and I can say, yeah, I want 5 glazed, I want a couple cinnamon, a couple more chocolate, sprinkles.
All right, now I'm
Which
hungry.
kind do you Huh?
Yeah,
now you're hungry.
It's lunchtime here on the East Coast.
Yeah, same. I'm also hungry, so let's do some more old fashioned. I'll hit order. Now that's going to send a request to my army of donut making robots, and it's taken a really long time. I wonder what's going on.
The live demo gods.
Yeah, well, but imagine I'm a user, right? Like I'm a user of this, and suddenly it's like, what's up? Why is this not working? I'm not even getting an error, so I'm just going to have to reload. I'm going to have to go through, put in my order again. You know, and maybe I actually get less this time because I'm frustrated. Still nothing.
Double credit card process.
Yeah. So these are the kind of things that can happen in your, in your application, right? If you don't have, maybe I've got logs and metrics that I could be going and looking at. Who knows, right? There's a billion different things in the real world that could be happening here. And without observability, all I would be able to do is look at maybe the console on this. Maybe I've got some logs on a computer. Maybe I do have some dashboards that are showing me like, hey, the error rate is elevated, but they don't tell me anything. So I'm going to order again. This time it worked. Cool. And now I'm getting, it's waiting, it's cooking, and pretty soon. All right, so it's done. It finished. I have my donuts now. Great. But I still don't know what happened. I don't know why things failed. So what I'm going to do is switch what I'm sharing. And I'm actually going to go to the code here. All right, cool. So this is the actual code of the application. This is our micro donuts sample, and you can see it's just a pretty plain Java application. And one thing I want you to notice about this is that there's really not a ton of logging or anything going on here. We've got, here's my route that adds a donut, talks to the kitchen service. Here's the kitchen service that gets in a request from the front end, and we'll try to fry donuts. But again, I'm not seeing a lot of logging statements. I'm not seeing a lot of metrics here. Best case, maybe I've got, this is running in Jetty, but if this was in Tomcat or if this was in, some container, I would maybe be able to get sort of black box metrics, right? I could get like, well, this timed out or this failed, and that goes to my dashboard, and I can see what's going on. And this is, I think, the state of a lot of, especially more enterprise applications, especially kind of your maybe more gray field.
Looks familiar to me.
Yeah, right. This is kind of a disturbingly common state of affairs. So what if there was a way to sort of alleviate this problem and maybe trace my application at the same time? So I'm going to open a terminal here.
Ooh, turn that font up a little bit.
So how's this?
That'll work.
Any better? All right. And so if I go, what I'm using here is something called the special agent. And the special agent is one of the challenges with tracing your code is you need to instrument your code somehow, right? You need to figure out a way to kind of, add logging and metrics and da-da-da-da-da.
Yeah, maybe it's aspect oriented programming. Maybe it goes right into the code with everything else. There's a lot of ways to skin that cat, and none of them are fun.
Yes, that's true. None of them are very fun at all. So what we did as part of OpenTracing, which is a open source project that LightStep is a big sponsor of, and also its successor, Open Telemetry, which I'll talk about later. But we built something called the Java Special Agent. One of the things that made OpenTracing very unique is that OpenTracing is simply a standardized interface to tracing. So there's no implementation of it out of the box. You have to plug in sort of Jaeger or Zipkin or whatever the actual thing you want to handle your traces. But that also is interesting because it means that you can create instrumentation for libraries without taking on a dependency to a specific sort of vendor or backend tracing system.
So
So
it sounds like OpenTracing's the framework, and the various tracing implementations are like a plugin model.
yeah, almost. That's we'll talk a bit more about it later, but that's a
Okay.
pretty easy way to think about it. So because of that, there's this wide variety of instrumentation plugins for things like I got a list right here somewhere. Things like OKHTTP, JDBC, MongoDB drivers, Cassandra, Kafka, Thrift, gRPC, sort of all the interesting things you might build your application out of. So what we made Special Agent do is it's a thing that can you can either add it in through the class path,
Okay.
or you can bundle it in through Maven, and you can set some configuration things at runtime. So now I'm going to go back here. I'm going to say run or make run with LightStep. It's going to rebuild this. It's going to start running it. And now, if I share my browser again, it's going to take a minute to finish loading. There we go.
It's getting there.
Yeah, it can take a little bit to load to do the instrumentation step when you're first running. But now, I mean, I've got my application here again, and I can go and I can say, let's do this order. Hit order. And you know, same thing is happening on this side, right? I'm still waiting, cooking, and so forth. But if I switch over to LightStep and refresh my view here, now you can see I've got this data showing up from the application. I didn't have to go in and add any kind of instrumentation code at all. I just, ran with these special config options to load the instrumentation. And you can see that I've got this get and post. I can move over into our data explorer, and I can actually see here's all of the requests that it just made while I was clicking those buttons. And I can see here's a post operation, here's how long it took, here's various tags, and I could add logs to it if I wanted to. So with this data, I'm also able to, I don't actually know if this will work because there's really only one component. Yeah. But I can see like, hey, here's all my post operations, and I can actually filter and view only those. I can sort by duration. I can see what took the longest time, what took the shortest time. And I can see up here too, here's this histogram shows me the length of time that it took for each of those. Now, one cool thing about this is since OpenTracing is not a since OpenTracing again isn't a big heavy big heavy implementation thing, I can actually bring in just the OpenTracing library, so just the API, which I've done up here.
Okay.
And if I go and I say, let's imagine that this was an application that maybe I'm like, we need observability in our app. So I'm going to take my existing application, I'm going to run the special agent, and that gets me kind of this high level get and post, right? Because it only knows about these sort of HTTP requests. It only knows about libraries that it knows about, that instrumentation plugins are for. But maybe I want to come in and add more instrumentation. I want to add something that makes useful information for me as someone that's running this application. Hey, I want to know what kind of donut it was, maybe. So since OpenTracing is simply a simply this API, there's a way to kind of say get the global tracer, which is something that gets set by what is it? Yeah, there it is. The global tracer is basically the current or the tracer for the process, which the special agent does set for me. So now in my kitchen consumer class, I have a tracer. And if I go to, let's say, this get donuts method, I can say create a span. I can call that tracer, say build span. As child of, and we'll ask the global tracer for its active span and start. So now I can do things like, all right, here's here's an error. If I had special error handling, I could put it in here, right? I could add a tag. Yeah, so tag. I could set an error tag maybe to true. Some of this would actually get done, I believe, automatically because of the instrumentation. But maybe a more interesting thing is, what if I just wanted to say, hey, what's the actual body here? Mm-hmm. So I could go in child span, log, body is already going to be a string.
So when a developer comes back and looks at this specific issue, they'll have not just the logs that are already built in and the machine data coming back, but they'll also have some, business level data as to what's going on at that point in time.
Basically, yeah, exactly. You can basically take your business logic and you can say, I'm going to embed stuff in these spans that is helpful to understand sort of the business logic here. So if I go back into microdonuts and then we'll run this again. And keep in mind that none of this time I haven't actually taken on a hard dependency on sort of any vendor, any tracer, anything, right? If I wanted to use this with Jaeger, which is a popular open source trace analyzer, I could. If I wanted to use it with, my own thing, if I wanted to make this work with Zipkin, I could. If I want to make it work with Datadog, I probably could, right? It's just creating a address already in use.
Ports in use.
Yeah, because this guy was still going.
Can't tell you how many times I do that a week.
Yeah, multiple terminals really gets you. So while that's going, let me switch back over to Chrome.
So right now, LightStep is just ingesting what OpenTracing is surfacing through the global tracer.
Exactly. So the instrumentation that's being added in through that through those instrumentation plugins and the custom instrumentation I just added, what's happening on the back end here is actually it's interesting. It's pretty straightforward. The tracer process that's being added into the Java runtime is taking these spans that are being created, batching them up, and then sending them to what's called a LightStep satellite. And we run a public pool of those. Most people in production will kind of run their own pool, but we have, for people that are kind of maybe in a smaller, that don't need as big of a deployment, you can use our public ones.
Okay.
And now when I run this, oh, I have filters on. What I should see is my new, oh, I forgot to do? I forgot to finish my span. So that's one thing about spans is since they have since that's a span of time, right? It means it has to have a start and an end.
Yep.
Um,
It reminds me of some of the Prometheus SDK stuff where, like in .NET, for example, you stick the metric in a using statement that just automatically disposes and closes it. Oh, yeah, totally.
yeah,
Understand.
there's a way in the Java and .NET worlds. You can use usings and with resources pattern to automatically close a span
Yep.
when something goes out of scope. I'm just lazy.
So we talked a little about Java and .NET. Which other languages, frameworks, SDKs are covered?
Basically anything you got. There's OpenTracing support in JavaScript, Ruby, Python, C++. Name a language, man. I've seen people use it in Perl.
How about Fortran?
I have not seen anyone use it in Fortran, but you probably could. I mean,
Adding observability to your mainframe applications.
actually, it's more common than you'd think. What people generally do, though, is they care about their mainframe because they've connected their big legacy backend stuff up to some modern front end, right? So they will have proxy services in front of it, and they'll actually instrument the proxy.
Yep, that makes perfect sense. I've got a talk coming up on moving the monolith to microservices and what it takes to break a monolith, and I talk a little bit about mainframes and all that as well.
All right, so here now we can see my new span showed up, my get donuts, and here's that log of, it just logged a bunch of stuff. But, without having to actually take on a hard dependency, without having to actually bind myself to a particular vendor, right? I didn't have to go in and use a specific, like LightStep tracer to write that instrumentation code. So Special Agent is a great way to kind of get started with instrumenting your applications, because one of the cool things is, hey, if all I need is sort of that top level get post, let me see stuff, then I can. If I want to go deeper than that, I can. So let me stop sharing real quick. So that's Special Agent in a nutshell. That's available on GitHub. It's under the github.com/opentracing-contrib/java-special agent. If you are listening to this and you want to know more about this or anything else I'm going to talk about, feel free to find me on Twitter at Austin L. Parker. I'm sure Jason will put stuff
links in the comments.
Links in the comments. You can also email me, austin@lightsstep.com, and I can point you in the right way. So let me show you a little more about LightStep that with a bit more information behind it, because Special Agent's cool. It's automatic instrumentation. Everyone loves it. What does this look like in a more real world setting or with a bigger application? So this is kind of our bigger demo. You can see here we have a bunch more services. So, and in these services, I can actually see each of my operations. An operation is going to be, generally operations are ways to aggregate sort of the spans for a service. So it's pretty common. We to think of them like this. Like if I have an API that does 4 or 5 different things, I should have each of those API routes is going to be its own operation.
Okay, makes sense.
These are ways to roll things up. So we can go down, let's say we have an API client. I can see like, hey, here's sort of each of the operations that that iOS client is capable of performing. I can see what's the latency change, the P50 latency, so 50% above, 50% below.
Yep.
Change in error rate, percent of errors, the change in error rate since a day ago, and I can also customize these, 1 day, 1 week, 1 hour. And then I can see over here my operations per second. So I can get, and one cool thing about this, I didn't have to, none of this data comes from a metrics API, right? All of this is computed off of your spans.
Okay.
So you don't have to do multiple different things. I can look at these streams here, and these are
so these spans are actually in the client, in the code for that specific client.
Right. So this is maybe something that you've really done a lot of instrumentation on.
Okay.
You can dive into any one of these streams, and then see like this historical data, and all these little dots are traces. If I want to dive into one, I click on it, and now I kind of this is probably when people hear distributed tracing, they probably think of something like this.
Yep. That's when I think distributed tracing, I think something like that. Absolutely.
Yeah. So here's what it looks like. Here's the everybody loves and hates the flame graphs. A couple neat things that LightStep does is, one, if you notice this yellow bar right here, this is our critical path tracing. So we're actually determine what portion of each span is on the critical path of your application. So you can see kind of if there's something that is taking a long time, you can kind of see like, hey, what's blocking other parts of my request.
Yeah, you can optimize the critical path by observing what's going slow.
Yeah. A couple other things that you can see here. We have a feature, this thing called workflow links. So this is one of the great benefits of distributed tracing is, you can imagine that I'm, a client, a front end, a mobile client developer, right? And I get Jira tickets or whatever that say, hey, this is slow or broken. I see this is like a 4-second request to reserve, whatever it is I'm reserving. I'm like, yeah, that's a long time, but I don't know what's going on, down in the depths of the system. I don't know how to troubleshoot this, right? And maybe I don't even know who to talk to troubleshoot. So with something like distributed tracing with LightStep, I can go in, I can see all of my different requests going down through, all these different layers of services, and I can actually, if I want to make it a little less busy, collapse some things. Here's our reservation, 1.1 seconds. This is where it kind of took the longest, this charge. And I can dig down and see, hey.
So you can look
at
each part of the charge.
Each part of the charge.
Okay.
And then I can see here, like, well, the longest single, thing was 689 milliseconds here to process the transaction. So what I can do with that data, maybe I'm not a person that works in the payment gateway, but you can use workflow links to, for instance, you could connect this to your bug reporting system, to your Jira, to kind of say like, hey, look at, search through Jira for this, or hey, there's this customer ID that's coming along everywhere. I want to look that up in our CRM and Salesforce or whatnot. Maybe I have I want to do a GitHub search for this method, for this operation, in my repository, so I can jump to the code that is relevant.
Well, it's all about getting feedback to the developers as fast as possible. I mean, it goes
exactly.
It goes right back into the second way of DevOps and amplifying feedback loops. And this, I mean, you've got direct feedback right from the end user in production to the developer.
Yeah, and I can even go down here into my more more details. I can see exactly like, hey, that's how much this is contributing to latency. I can look at the host name for it. And we use all this information that we're getting to effectively create, there's this whole, I mean, I don't know. I remember certainly the most fun part of our jobs back at Apprenda was fun part, right? Is the investigation, right? Is
Oh yeah.
someone, a customer or a client or an end user or a teammate or whoever says, I've got a problem.
And
And
it's offsite.
it's offsite, it's somewhere else. You don't have access to everything you need. And you have to go through and you have to develop all these hypotheses before you can really start doing anything else. What LightStep does is LightStep takes that hypothesis generation step and kind of says, well, the computer knows more about what's going on than you do. The computer can process vast swaths of data and hold it all in its memory at once and kind of create compute insights or whatever. Like, what if the computer is giving you the hypotheses and then gives you a way to go and validate those hypotheses, right?
Yep.
So that's one of the things with our correlations feature here. I can say, like, here's P95, so here's everything that's slower. Here's the top 95% of requests in terms of speed. So let me select those, and then we do something called correlations, where we look at those tags that you're sending that are being set by your instrumentation and looking for what's strongly correlated between the things that I've selected here and everything else. So here's a good, if I'm saying, someone's saying, oh, there's a problem, I go in, I select that, and I'm like, okay, well, seems like a lot of things in US West 1 are pretty slow right now. I can look at release tags, right? I can say, well, what's the difference between version 1 and version 2? So if I do not want to enable dictation, if I filter just to version 2, I can even look and see how these are changing over time. Mm-hmm. So I can say, what's version 2 now look like compared to an hour ago, a day ago, a week ago? And I can see, like, it's pretty steady state. So maybe the problem actually is something to do with the network it's on, or the host it's on, or any of these other tags that we're correlating for you, right? So that's a sample of the kind of stuff that LightStep is capable of doing. We can take all these information, we use the fact that it's all correlated by the nature of trace data, and we can build these hypotheses and insights for you very easily, and yeah, I mean, we create kind of that first step in debugging and firefighting, in I just woke up at 3 a.m. because I got paged, what the heck is going on? That's the sort of stuff that we're fixing for you, or at least we're making it easy for you to understand that data.
That's pretty cool.
Yeah. This is the service map, so like you can understand. We're using the fact that the data is all connected to build this for you. Like, you don't have to actually tell us anything. And if you're using Kubernetes, this actually gets even easier, especially if you're using a service mesh, right? Like Istio, because Istio actually out of the box has support for LightStep built into it.
Okay.
So you can turn that on and see like how it actually works is it's integrated into Envoy. So every sort of hop that your application takes, you would get a span for. And the code to actually integrate that into your business logic looks a little different. But you can do something similar to what we did with Special Agent.
Okay.
To pull the active span out of the request and kind of go from there. So that's sort of an overview of LightStep and the current state of the world, I guess, with instrumentation.
Okay. So yeah, I noticed you mentioned Open Telemetry. I saw that LightStep was co-founding Open Telemetry Group. So tell me about that.
Yeah, so Open Telemetry, actually have slides, but they're probably not that interesting for a while. um, the idea with Open Telemetry is pretty much this. For, I guess it helps to understand a little bit of the history of OpenTracing.
Mhm.
OpenTracing was 2016, 2015, let's say, is kind of being developed several years ago. And it, in a lot of ways, springs out of the work being done by Google and other companies, like even earlier than that, in the early mid 2000s, on a project called Dapper. And Dapper is what one of the principal engineers working on Dapper was our co-founder Ben Siegelman. We have a lot of kind of people that were connected to that at the company. And Dapper was this idea of where spans came from, effectively.
Mhm.
If you want to read more about this, Ben actually wrote a blog on our site that's pretty fun read. The people don't really like the word span, or I think it works for what it is. It's the span of time. It's a unit of work. But anyway, so OpenTracing was developed to sort of meet this need, which was, hey, there's this thing called tracing. People want to use it, but people want portability, right? People don't like generally when instrumenting code or using developer tools locks you into a given vendor.
Yep.
You know, which is it's why I think you can see this in logging a lot, like why like logging shims and frameworks got extremely popular for a while there, until at least in the .NET world, until kind of Microsoft came around and said, okay, well, what if we make our logging framework not just tie you to Windows?
Yeah.
So OpenTracing was developed in this sort of world where the important thing was a API that was portable, that could be implemented in a lot of different languages, that was relatively, didn't tie you down too much to certain decisions, but that everyone could support. And that's generally what happened. Like if you look around at the market now, if you want to start instrumenting code today, you can go out and you can find OpenTracing compatible tracers for pretty much every single major APM vendor, right?
Yep.
Datadog supports OpenTracing, SignalFX, now Splunk supports OpenTracing, Honeycomb, LightStep, da 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 da.
Mhm.
Sort of a couple years after OpenTracing started to sort of get out into the world, Google took something called Census, which was a enhancement of the sort of stuff that came out of Dapper,
Mhm.
and open sourced it in Open Census. And Open Census, the big difference between Open Census and Open Tracing was that Open Census provided you sort of a batteries included package, right? With Open Tracing, you had to not only, you had your API, which was abstract and portable and great, but if you wanted to actually use it, you needed to have a, trace analyzer, you needed Jaeger, or you needed LightStep. Census actually had implementations of its API bundled together. So you could download Census and kind of just use it without having to install anything else. They had an exporter model that meant you could kind of take your trace data and forward it to multiple different sources or sinks of trace data. So you could use Jaeger and Datadog if you wanted.
Okay.
And another thing that it did was it included a metrics API.
Okay.
Because there's a lot of things that you can derive from trace data in terms of metrics, aggregate metrics, but there's a lot of reasons that you might want your own metrics API and your own metrics provider type of stuff. A good example would be specific operations, right? Like if you want a count of how many times someone clicks thing A versus thing B as sort of an experiment.
Mhm.
If you're doing like front end stuff, or in the back end, you might want, you know, if you have a specific SLA with another service or a third party tool or vendor, then maybe you would want to capture that whatever you're tracking to ensure SLA compliance as its own metric.
Okay.
So having a metrics API that's part of your telemetry package became very useful. And what we saw in the community was there was a lot of people, third-party developers in the open source world, that wanted to add instrumentation to their libraries and frameworks. And they said, I'm really confused. There's, OpenTracing, there's Open Census. What do I use, right? Like, I don't know, and I can't, in some cases, I can't tell the difference between these two things. So that led us to start talking to the Open Census people, and earlier this year we announced, hey, we're going to merge these two projects into one new project, which we decided to call Open Telemetry.
So Open Census plus OpenTracing is becoming Open Telemetry.
Exactly.
Okay.
And the idea behind that is really a best of two worlds approach. I can actually, let's do a couple slides here. So with Open Telemetry, what you're getting, I'm just gonna, people can see these, cool, it's fine. You're getting the API, and the API will be independent from the, or will be separate from the implementation. You're getting the actual implementation, of course. You're also getting standardized data formats, and then a lot of interesting new tools built on these things, like agents. And also, this will be backwards compatible with Open Census and OpenTracing. So one, sort of the minimal version of this looks a lot like OpenTracing does today, where you have an API with some sort of, no-op or mock thing hooked off to it. And if I'm a third party, if I'm making a library for other people to use, and I want to say, oh, this supports OpenTelemetry, I would just import the abstractions and not the implementation, write my instrumentation code against that abstraction, and then I don't care about it, right? Someone can come later, import it into their program, and import the OpenTelemetry SDK, and it'll suddenly like, aha, I have all this telemetry data. You've got a full sort of batteries included approach where you've got that API and then the SDK.
Mm-hmm.
And then another neat thing is we support reimplementation of most of the SDK. So if you are at a company and you've already got some sort of tracing or metrics library that you like to use, you can integrate that in by reimplementing parts of the OpenTelemetry API and kind of mix and match, use what you want.
Okay. That's a nice design.
Yeah. If this is something that interests you, you want to read more, we have two places to kind of follow along. So if you're interested in sort of the specification and the RFC process, that's over here at the Open-Telemetry organization in GitHub. Open Telemetry specification for the spec, and then OTEP, OTEPS. These are our RFC process. So if you want to make suggestions or big changes. We also have a little status update if you want to know how you can start using this. The tracing API is pretty stable. I think we're calling it beta now, or it's practically beta. And then the metrics and context API should be in beta pretty soon. I think the metrics and context should be in alpha end of this week, beginning of next week. I want to say the 15th is what we're saying right now. For the actual SDKs where you can use this, the first 5 languages that we're really pushing for are C#, Golang, Java, Python, and JavaScript, Node.js, so server side, but also browser. And those, I think those should all be in alpha by the end of this month, beginning of next month. browser JavaScript might be a little after that.
One more set of things for me to read.
Yeah. Well, hopefully this
I can't help
will.
myself.
Yeah, no, I mean let me go back to our fun XKCD, the one universal standard comic.
Yeah.
We were feeling this though, right? There was a lot of confusion. So one other thing that to keep your eye on is by combining these projects, we've actually really expanded the contributor base of Open Telemetry versus what OpenTracing had. OpenTracing had hundreds, I think thousands actually, of contributors over time. But with Open Telemetry, we've actually brought in several more corporate partners. So Google, Microsoft are both big corporate partners on Open Telemetry. We have contributors from a wide variety of monitoring and observability companies. And because of the fact that we have more people now, we can sort of promise some, well, we can talk about these bigger ideas, right? Like, we started off with special agent, right? We started off with automatic instrumentation. So two things actually that we're interested in doing are providing that sort of first class drop in auto instrumentation for every language. So not just Java, C Sharp, Ruby, Python, JavaScript, Go, whatever. And the second thing is better integration with other large open source projects. A good example of this is Kubernetes.
Yep.
So we're working with the instrumentation SIG on getting OpenTelemetry added into Kubernetes. So you would be able to trace your cluster. I think right now we're talking about the API plane.
Okay.
But I can easily see that being extended to like routing components so that, the dream obviously would be you deploy any application on Kubernetes, you plug in an exporter to whatever your monitoring system is,
Mm-hmm.
and you can see both, system level stuff. So you can see like, hey, I'm deploying a thing, show me a trace of that container getting deployed or
Yep.
that workload happening. But also show me the requests, kind of moving through the system. Show me, I have 20 different containers. Here's how they all connect. Show me that.
Okay.
So that would be kind of that would be a thing that I think we would love to have happen. And we, I don't know how long it will take, but certainly with the sort of institutional support that's behind OpenTelemetry, I feel like we're well positioned to make those sort of things real.
Cool. Well, I mean, I'll definitely lean on you. So one of the things we didn't talk about what I'm working on, I'll show you a little bit here, is this project called Cattle Drive. And the idea behind Cattle Drive is that it is an open source, community driven reference architecture for Kubernetes and for Rancher. So it's github.com/my name, Jason Van Brackle/cattle drive. And this is what I've been working on the Ranchcast for the last, number of episodes. And the reason, I wanted to have this talk was to start, thinking about telemetry as part of the reference architecture, because it's not just the day one concerns, it's all the day two stuff too that we should be concerned about, and day two should consider observability, whether
Right.
it be metrics and logging and tracing. So I start looking at Open Tracing. So I'm definitely going to lean on you for the telemetry part of this, and so part of this is actually become a full blown project.
Mm-hmm.
Where the MVP will actually include the idea behind tracing. So I'm going to ping you here and there. It doesn't necessarily be live here. Some of this will happen live. Some of this is happening, behind the scenes. But yeah, definitely that's kind of where I'm going. It's one of the reasons where when I reach out to you, I'm like, this would be a really cool thing, and I think it's something we should be talking about in production. That goes well above and beyond just the things that we've been thinking about in the Kubernetes community for the previous 3 to 5 years that were just around provisioning and automation.
Yeah, I mean, I've done some talks about this specifically, talking about tracing as sort of a day zero consideration.
Hmm.
Um, there's some really cool sort of talks about this. One of them was at KubeCon last year, I want to say, the North America KubeCon
Hmm.
in Seattle. Ted Young did a talk on trace-driven testing.
Okay.
So the basic idea is traces are a lot of things, but the basic fundamental structure of a trace is it's a collection of spans that have some sort of causal link, right?
Okay.
So span A and B and C and D are connected. If you take your code and you sort of instrument it as you go along with pretty detailed, right? Let's say,
Hmm.
you know, every time I'm calling a new method, I'm creating a span and connecting that to the method that came before.
Yep.
You could take that trace data and export it as some sort of, in whatever format you wanted. And then you could run that same code and take the trace data it generates in different environments and then diff them,
Okay.
right? So
Yep.
I could have a simple service that's running on my laptop and create a trace from the execution of the program for certain test cases. So for all these different, I say, here's a bunch of inputs. Cool. This is what I expect it to do. Then I could deploy that to staging, run the same set of inputs, take the output, compare them. Are they different? Did something change? Is there some sort of like one of the biggest things, if you look at the world today, like what is kind of killing us right now in terms of reliability? A lot of times it's config.
Yeah.
It's stuff that happens at runtime that we can't test for, we don't test for. Um, Traces could be a way that would let us sort of figure this out because we could apply our config and sort of staging environment or whatever, and then compare the output against our known good or our canonical trace, and automatically flag, hey, yo, this is different, this is weird, this is a problem, right?
Yep.
Another way to think about this is to go even a step back and say, like, okay, well, maybe I don't need to go down to the method level. Maybe I just care about the relationship between all my different services. And I think that's really important if you have a very large microservices architecture, because I might I might say, okay, here's my team is going to build this little service and we're going to put it out there into the world, and we depend on it for a couple things. But over time, other teams discover, hey, that service is something useful. I'm going to build a service that depends on it, and so on and so forth. And now,
Invisible scale.
right, I've got this scaling problem that I don't even know about as the original author or maintainer. Um, I just see like, wow, this request rate, operation rate keeps going up really high. So I could do that same sort of approach of taking my trace data and using it to map to model the actual, like, here's all the services that depend on my service and I depend on, and here's a trace that shows the state of the world, and then as new services are deployed, it gets diffed against that known good model and can issue whatever, right? It could issue an alert that says, hey, this week you've had 12 there are 12 new services that depend on you, right, transitively or whatever. So that when I talk about like day zero or trace driven dev, it's really about taking these principles and concepts of tracing and bringing them back down, because for most people, I think, um, especially the ones that aren't sort of embedded in this world, we tend to think of tracing as I tend to think of tracing as like, oh, it's a dev thing, but most people think of it as sort of an ops thing, right? Like monitoring in general, monitoring and metrics and logging are stuff that someone is dealing with, like after I've handed off the code,
Yeah.
after my service is running. So what I would love to see is Open Telemetry and all these projects making it easier for developers to get involved in writing their own instrumentation, instrumenting their own code, thinking about how it can be part of their day to day rather than just something that someone, some person in another office is dealing with,
Yeah.
to understand how it works.
Collaborative ownership of a project or a product.
Yeah, right.
Yeah.
Like, this is DevOps thing that we keep talking about.
Yeah. Cool. Very cool. So before we go for the day, anything else you want to share?
Yeah, so if you are listening to this and you really like listening to me talk, you should listen to my podcast, On Call Me Maybe, a podcast for the monitoring era. You can find it at oncallmemaybe.com, also on most of the places that you listen to podcasts, like Spotify, Apple, iTunes, and
And
Google
some links
Podcasts.
down there in the comments again.
Yes, links in the comments. You can find me on Twitter. Um, and let's see. I'll be speaking at a conference in Canada that's full, so you all won't be able to come to that. Um, and I'm writing a book to be
Oh,
published in
cool.
Q1 2020 from O'Reilly called Distributed Tracing in Practice.
Awesome.
So look forward to that if you want to get more into distributed tracing.
I'll be looking for the pre-release. That's cool.
Yeah, I think it's in early access now.
Oh, awesome.
So if you are on Safari, then or whatever they call it these days, I think it's still Safari.
I don't even remember. I go there and I've looked at the title in years.
Yeah, you can go read the first couple chapters that are still being edited and reviewed and stuff. But trying to think, I think that's it. I mean, I'm around. I'm on the internet. Give me a holler if you want to learn more. And if you want to learn more about LightStep, then we are at lightstep.com. We have a free trial available. So if you want to get started instrumenting your code with Special Agent or anything else, then you can do that there. And if you want to work with us, we're hiring lightstep.com/careers.
Awesome.
I think
Very
that's a lot of plugs.
I'm okay with plugs.
All
So,
right, yeah, I got a lot of things to plug. So
no, open source is awesome, and vendors help make open source awesome. So, that's I'm all for shameless self promotion, plugs, all of that. So, Austin, thank you so much for sharing with us. This has been really cool.
yeah, thanks for having me. I'd love to come
The
back.
ideas in my head are just like totally spinning now. So, expect to see me out there in the community as Open Telemetry takes off, because it's right up where I'm going as far as helping teams adopt DevOps, adopt Kubernetes, adopt Rancher, all of these things. So, awesome.
Cool, yeah, definitely, and I'd love to come back and work with you on your on adding telemetry to your project.
Cool.
Sounds really
No,
cool.
we will get there. Adding the issues to my project probably this afternoon. So,
Cool.
thank you so much, and to everybody else out there, to the Rancheroos, to anybody else who just happened to come on because they saw us on Twitter, hit the subscribe button and join us next week. It'll either be 9 a.m. Eastern or 12 p.m. Eastern, just depending on what other things Ranger is doing. I don't like to step on Lead Chen's toes. So, that being said, goodbye for today, and we'll see you next week.
Ciao.